In this video, I want to show you what possibilities you have by changing belt parameters within the OpenScad customizer. The customizer in OpenScad allows you to change parameters. Let's have a look. So for example, if I change one of the parameters, let's say the belt height, to something different, and you will see immediately the complete thing will change. The customizer in OpenScad allows you to change the parameters of your design without having the need to change something in the program code. In fact, you do not need to modify anything there unless you do not want to add some new features. Generally, I will not explain all of the roughly 60 parameters here. Many of them explain themselves. Let's start with the general section. The visible parameter defines which part of the view of the belt you want to see. For example, we first go to the all mounted preview. All mounted, you see the complete belt, how it would look like, you have an idea how it would end up when you create it. The next one is the belt segment. So if you want to focus on the belt segment, for example, if you do some changes, you can do that here. If you look at the belt tip view, you can do some changes on the belt tip. And if we look for belt tip parameters, and you, for example, want to change the tip radius to something different, then of course you can do that here. So it makes sense to switch to the correct setup. So go back to general, and then of course you can see the different parameters. So what you can do anyway is we have some presets. For example, you want to look at some different setups and you have no idea what is possible. Just go through this and you will see if you look for something different. So yes, of course, I don't want to keep it. So now it shows you a completely different design with different sizes and so on. So you can just toggle through. So you can make another straight one with a pattern. You can choose also different kind of patterns. And also, for example, if you now go for small angles, it's about 15 degrees with a different pattern and so on. So you just had to get an idea what is possible. You can also add some text. Yeah, you can see you can add your segments and change your segments and you get some text out of it. Even you can make some very small segments. You can talk through this to have an idea what is possible, what kind of things you can do. But we're talking about the previews. So let's have a look at the next one. And now let's have a look at the inner buckle, because the inner buckle is an important part. You need that always at the end of the belt. You can see the outer buckle part, which is also a separate view. So if you focus on this one, you want to change something here, you go to the outer buckle view. Then of course you have some print inner buckle and tip. This is actually intended if you want to print that one, because it's now positioned already that way that like you put it on the printer bed of your FDM printer. So that means typically the tip and the inner buckle can be printed together. So therefore you have this view. So the only thing you have to do if you want to export it, you just do rendering. That's a common thing in OpenScad that takes a moment. Once it's ready, you can save it as an STL, and it's asking you where you want to save it. So we have the STL file you later can use, load it in your printer software, and then you can start printing your parts. You have another print view for the outer buckle, because the outer buckle needs to be printed upwards, because this one is the layer where you put it onto the printer bed. The reason is it needs stability. So if you print it, let's say the other way around, like this way, for example, if you print that way, and this is on the printer bed, then you have your single layers of your prints in between, and that's not stable enough. So if you would load some pressure onto the buckle, it would rip off. So what you need to do, the best for printing is really this way. And then normally you need to put some raft underneath so it's stable. At least that's what I did on my printer. The next one is the cut preview. That's sometimes helpful if you want to see if your buckle and your squeezing inside the buckle may function later correctly. Usually it does if you select the correct angle, but you have the possibility to change, and so you can double check inside your cut preview if this is still about to function. When we talk about the different parameters, generally I do not want to talk about all of the roughly 60 parameters we see here inside the different sections. So I will focus only on some that may not be too obvious. So let's start with the general section. So if you look at the general section, the visibility we had already. Here we have the next one is the play gap. That's an important thing. If I put it to 1 millimeter, you will see the gap in between is considered as 1 millimeter. Because normally with the FDM printer, usually parts become a little bit bigger. And usually the standard thing is about 0.25 millimeters. And that's the reason why the standard play gap will be 0.25 millimeters. You can even put it on 0 if you have a different kind of printer, which creates the parts very, very exactly. So you can make it very small. So just to have the sizes of your parts correctly. So belt height is explaining itself. So let's go for the belt height. I go to the all mounted preview. So you can even see here, for example, this is the belt height. If I change that one, the belt height is now 41 millimeters. I make a small one, 11 millimeters only. You can see you can define the belt height as you need it. The next one is the segment add. That's something you need especially for straight designs, because the segment add, it adds some additional distance to your belt. Yeah, you can see you can have some thing inside, and by changing the segment add, you just extend the size. Usually this is only necessary on straight designs. For example, if I go for the segment add to 0, you will see what happens. Actually, we have no more connection here. So because it's on 0, there is no addition from that one. But as soon as you start, for example, changing the hinge angle, so the angle for the hinge, yeah, then of course you suddenly get enough space. This is because you can see here it's on 0, and so they're directly connecting these two slants. Yeah, and they don't need an add. But you can also add something here. You can put some segment add here, then it will become a little bit bigger. You see, you can define your sizes of your segments in a wide range. The pin diameter defines the diameter of your pin, and you may wonder why you don't have a belt thickness. The belt thickness is just given by the pin diameter on one side. So if I, for example, change to 3.6 millimeters, now you will see also the belt thickness will become bigger. And the next parameter that defines the belt thickness is the hinge wall. That's actually the thickness in between the hole and the outer side. So if I make a bigger one, a bigger hinge wall, at the moment it's 1.2 millimeters, let's say 6 millimeters, you see it will become quite huge. Yeah, don't know if this makes sense. It's up to you. Anyway, still the whole belt may still function. Yeah, so it's not that way that by changing some parameters it goes completely wrong. So I took care that usually you can use almost any parameters. I don't know if that such a belt makes sense, but still you see it's a possibility. So the next thing was the hinge handle, the body wall. The body wall, that's actually the thickness up here that tells how thick your body will be. At the moment it's too much, it's 40 millimeters, because it's then filling up completely. But if I make it very thin, for example 1.3 millimeters, you see it's becoming thin. And if I go to 1 millimeters, that's the minimum yet, because it doesn't make sense to make it smaller, because otherwise your parts will not hold anymore. But what you can see, the body wall, really, it's possible to adjust. So let's make it a little bit in between, 5 millimeters, something like this. And you see it's now 5 millimeters, roughly like this. It's also depending much on your size of your belt. So if you make the belt height a little bit larger, for example, also you have some more space, of course. So you can change within a big range to different kind of designs, of course. The next one is the jaw strength. That's the relative thickness in between these parts and the middle part. So we call it the jaw because you can take it as a mouth which catches the prey. Therefore I called it that way. So let's say the jaw strength, make it a little bit bigger. You see it will become thicker here. You can even up to 70%. Then your belt will look, of course, completely different. But the question is if that makes sense. It's up to you. The next thing is the setback. Because, for example, what you can do is you can use some string, for example, as hinges here. Because at the moment it's just a hole. You can see, if I look through, you can look through, you see, it's just hollow inside. So you could theoretically use a string to connect these different things. And if you use a string, maybe sometimes you need a little bit more space here, because otherwise you touch the inner side of the buckle. So therefore, you can use setback. For example, it's now 1.6 millimeters. Let's go to the maximum, 5 millimeters now. You can see you can put back the jaws so you have more space here. This one is just for the all-mounted preview here. You can see how many doubles you want to see. For example, if you want to see only one, it's calculating a little bit quicker. But if you want to see the complete part, you make the number of doubles a little bit higher. Then this is something that is perhaps interesting because this is the fixed layer thickness. At the moment it's on 0. You see a little part in here, so it's just a SVG file. And if you put the fixed layer thickness to, let's say, 1 millimeter, you don't see anything at the moment because this is just a positive part. But if I go into import SVG, and I now import SVG, so open that one. And if I now say, for example, the SVG thickness, I add a little bit more to it. So what you can see now, it's adding some thickness to it. Yeah, and you see, you still have that part. Yeah, let's make the file scale a little bit larger. Yeah, so you can see maybe a little bit better, or let's make it a little bit smaller. The SVG thickness, say 1.6 millimeters around. So now you can see on the inside there is something, it's solid. If I put my fixed layer thick to 0, it will be okay. It will be still hollow. But now you can see there are some parts which are completely loose. This one, for example, is loose, and this one is loose. If you print it that way, of course, at the end these parts will fall out. So they're not fixed with a complete thing. So therefore, you can use the fixed layer thickness, put it, let's say, to something like 1 millimeter. That makes sense. And it puts an additional layer inside in the middle here. Yeah, just to put these parts together. On the other hand, you cannot look through. That's the downside on it. But it's on your decision what you want to do. So let's make it a little bit smaller. SVG thickness, so a little bit smaller. And then you can, for example, combine it with a pattern. So let's say if you want to choose a pattern. At the moment there's no pattern, but let's say we use something like a honeycomb. And it's recalculating it, and it's putting a honeycomb in behind, and you can see now you can define and combine, let's say, SVG files together with some patterns. Yeah, you have lots of patterns here, so you have a big choice to choose the design of your particular belt you like. So there are maybe some other things that we have to talk about. Most of the parameters in the SVG and in the text section will explain themselves. So let's make them a little bit smaller again. So the SVG and the text and the general. So in the text section, pattern section, and text options and text transform options, import SVG and so on, it's more or less self-explaining. So don't worry, have a look at it. You will figure out what it does. The next thing is the belt tip parameters. It's also more or less self-explaining. There's not much to it. But the next thing is the buckle parameters. Might need a little bit explanation. So think about, you use a string now. You use a string to bind your segments. For example, a string that goes from here, goes up, goes down, goes up, goes down. So it will, perhaps depending on your design, it will move up here, and what it does in addition, it will be there, and therefore you have the so-called string space. So if you want to have a little bit space in the buckle, you can select it with a spring space. If I remove that one, it recalculates and the buckle becomes smaller on one side, and you don't have the spring space anymore. So the buckle size will become a little bit smaller, therefore. The next one is the easy print inner. That's also not too obvious. It's actually interesting for the inner buckle. So let's switch to the inner buckle. Easy print. You don't see that at the moment. So because the whole thing is too thick. But let's switch, let's say, to the default design. So that's the default design. And then we go back to the inner buckle. And on the inner buckle, when you look here, because you want to print it on this side, usually on a FDM printer, because theoretically, if you have a different kind of printer, you can print it the full size, with everything. So now you see these guides here, they go even a little bit up here, and you can see even this one is, by the way, the string space. This cutting off from the string space does that also. If you remove that, you don't have it at all, but it's exceeding this part, and printing it this way on an FDM printer would mean you have to put some support underneath, which you probably don't like because that's a lot of work to remove it afterwards. So what you can do, easy print inner, so you just click onto that and it's cutting off that one. It doesn't really hinder the movement afterwards. It's just a little bit less guided, but that really doesn't matter that much because the most guide is done here on this surface. The next one is the wall. The wall, just let me show you what happens. Go from 3 to 4 millimeters. Now it went up to 4 millimeters. So my guides became bigger, you see. Also my cutoff becomes bigger here. So I can define how thick my wall is. The wall is actually a parameter that is used several times. It's used, for example, for the stop block, because that's the end stop for the buckle, inside the outer buckle. So if I switch on to the outer buckle, here into the outer buckle, so then I can see here my thickness of my walls here is 4 millimeters now. So if I go to the wall thickness, to a different one, that's also an important parameter. So if I go to 1.5 millimeters only, I don't think it makes sense to have less than 1.5 millimeters. Now it's very thin, you see. My guides are smaller, and also my walls of my buckle are smaller. So I can define with this one how large my buckle will become, or how thick or how stable it becomes. So I can even, if I say I want a bigger wall, let's say go for 6 millimeters, which normally doesn't make any sense. You see, you have a lot of space inside. So it's now quite stable, but it's up to you what you define. So let's see what else is important. Clamp range, that's an important one. This is actually defining the length of the buckle. Therefore, it's best to have a look at the cut view where we can see both. So the inner and the outer buckle. And that is actually, if you move the inner buckle compared to the outer buckle. So you can move that one, and by this one, you squeeze the inside. And by moving it, you can define how much it moves from the lower side to the upper side. And that's defined here. We say, okay, at the moment it's 0.7 millimeters, right? So I can go to 0.1 millimeters only. Therefore my buckle will become much shorter, right? Yeah, but I don't have to move that much here. But 0.1 millimeter, your prints would be very, very exact to still squeeze it. So I think you should have at least 0.5 millimeters to still squeeze it. But you can define, and if you, for example, say the clamp range, make it a little bit larger, or you go to 1 millimeter, then of course your buckle becomes longer because you have to move it for a longer way, of course. Yeah, and that's also depending on the wedge angle. So for example, if I do a small angle only, let's say 1.0 millimeters, then of course, if I have only 1 degree of slant, I have to move a lot. And then of course my buckle becomes long. I don't think that this makes sense to have 1 degree, because even if you have this 1 millimeter and it squeezes, you would have some trouble that it stucks at the end. So my personal point of view, if you have a clamp range of 0.7 millimeters, that's normally sufficient, or 0.8 maybe, using of course a wedge angle of, let's say, if you use 10 degrees, then of course it's going up 10 degrees. You don't need to move that much. But on the other hand, the angle is quite steep and you have the risk that your buckle loosens by its own while you wear your belt. So I think a good wedge angle is about 5 degrees, 4 to 5 degrees. You even can define the so-called belt overlap. That's actually this part here. So if you go for a belt overlap of 0, you will see this will become just an edge here. The buckle will become a little bit shorter. So if I make the belt overlap very long, 20 millimeters, you see it's becoming, the slant becomes bigger. So the next one is the minimum slant length. You can say, okay, a minimum of my slant should be, let's say, you can even say 45 millimeters, and you can define how long your slant should be, just to make it stable enough, right? So usually you don't need this. But if you want to have a longer buckle because of the design, you can do that also in here, so the buckle becomes longer. So the next thing is this thinnest wedge, because you see this part here is the thinnest part, and if you have a very strong design, this may be the weakest point. So you can define this thinnest wedge. You can make it to 40% of your buckle width. That's now 40%, or you can even make it 100%. Then you have more, but of course your buckle will become a little bit thicker. These are the things you can do, and I hope you have some fun with the design. If you find some problems, let me know, drop me a message, and I will look to make a change. Thanks for watching.